Hello, today we're starting a new project. We're going to turn all of this into this. So basically what we have here is a current, as of the recording of this video, Raspberry Pi, a case for the Pi, a power supply, memory card, an inexpensive SDR, NooElec SDR, a couple of cables, my quadrifilar helical antenna, and we're going to put all of that together to make basically a headless satellite receiving station, and hopefully it all works out.
Now we need to set up the Raspberry Pi. The first step in that is getting the Raspbian image copied over to our SD card. You can download the Raspbian image from the Raspberry Pi website. There's also instructions on the website about how to copy that image over to the SD card. Now that we have the image on the SD card, we simply need to assemble the Raspberry Pi into its case. You don't technically need a case for this, but I didn't want the Raspberry Pi just banging around in my attic without any sort of protection. So I got the simple case. As you can see, it just sort of snaps together. Now we need to boot the Raspberry Pi for the first time. As you can see, the first boot does some housekeeping, and then the Raspberry Pi will reboot into the Raspbian OS. The Raspberry Pi will automatically log in with the username Pi. The password for the user Pi is Raspberry, just in case you need it. So now the first thing we need to do is connect the Raspberry Pi to the network. We're going to connect to my wireless network here, and, well, sorry, you don't get to see my Wi-Fi password. It's now connected, and we're going to run the Raspberry Pi configuration utility to set the Raspberry Pi to boot to the command line. We don't need the GUI running, no sense in wasting resources. And we're going to go ahead and enable SSH. Next up, we'll open a terminal and just check what our IP address is. We're going to make a note of this IP address because this is the IP address we're going to connect to later on when we use SSH. Now we'll do a quick reboot just to make sure the Pi boots up properly into the CLI and keeps the same IP address. We'll run ifconfig again, and sure enough, we have the same IP. We are on the network. So now that we have the Raspberry Pi up and running and on the network, I have shut it down and repositioned it in my attic. It's connected to my SDR dongle, which is connected to my antenna. So the hardware side of this is all ready to go. Now on the screen here you can see I'm running Secure CRT, which is an SSH client. You'll need an SSH client of your choice. If you don't have one, I recommend trying out Putty. It's free and it's a pretty solid client. You can just download it. It's Putty. You can just download it from the internet. I've connected to that IP address that we noted from the setup when we did wireless and we ran ifconfig, and that was set up over here in this window. Now in my other window I've got my instructable on how to construct this satellite receiver. I'm using this as notes for what to actually type in because I'm doing this from scratch again, so I want to make sure I do it right. So the next step is to update the software on the Raspberry Pi, and to do that we're going to run these two commands right here. This one. So many of these operations that we're going to do today are going to take quite a bit of time because the Raspberry Pi is not the most powerful computer ever created. So some of these operations are kind of slow, and I'm doing this over wireless. Granted, I have a decent wireless and a pretty good internet. It still takes a while to do some of these functions. So during the time, I'll either skip ahead or fast forward the video, so we don't have to sit here watching paint dry, so to speak. And we're back. So now that we have the Raspberry Pi updated, I'm going to go ahead and do a quick reboot. Because this thing's boots so darn fast, it doesn't really harm us to do so. It doesn't take much time. And it's probably a good idea to do that after upgrading the software anyway. And it's back up already. That's how fast these things reboot. Now let's move on to the software installation phase. And we're going to have to install a couple prerequisites here. These are all documented in the Instructable, which will be linked down in the description, so you can follow along as well. So the next step involves creating a new file in this modprobe folder. This file will instruct the kernel module loader not to load certain modules when it boots, so that we don't have contention for the SDR dongle. Now you need to make sure to run this step as sudo so that you can actually write to this folder. So I prefer to use VI, but feel free to use any editor that you choose, any text editor that you choose. Grab these three commands and done. Now it does require a reboot after changing that modprobe file, but we're going to go ahead and do a reboot here just a little bit later on before we actually do anything interesting, so there's no need to reboot right now. The next step is to install the Rtl Sdr software. Now we could just use apt-get and download it from the repository and install it that way, but that version, it doesn't include one of the options that we need, which is to actually get the output in a WAV format. So we're going to go ahead and download a newer version of the Rtl Sdr software, which is source code, and we'll have to compile it. Now don't get too concerned about this. This is a pretty easy compile, so we'll just follow along here with these commands and we should be okay. So the first thing we're going to do is go ahead and cd to our root directory, which we already are in, our home directory, and then we'll go ahead and use this command to download the software. Now, there are a couple errors on the screen. Now I've got this last time that I tried this as well, and it worked just fine. So we're just going to go ahead and ignore these unsigned decimal constant errors and move on. And here's that reboot I was talking about before. Love how fast these things boot. We're back in already. Alright, so the next step is to install a program called SOX, which is an audio manipulation software package that will allow us to change the frame rate and a couple other things in the audio stream so that we can actually read these images. The next thing we need is the @scheduler. It's a scheduling program that's much more flexible and a little easier to use than cron. And we're gonna go ahead and use that a little later on in our scripting to automate the process of of actually processing, downloading, or receiving and processing the satellite images. The next thing we're going to need is a way to actually know when the satellites are passing overhead. And to do that, we are going to use a software product called Predict. We'll go ahead and install that. And the final thing we need is a software package called WX2IMG. And this is the software that actually goes ahead and converts the audio file that we have recorded using the other products, and it converts it to a visible image. So this is where the rubber meets the road, so to speak. Oh, looks like we need sudo to do this. So don't forget, we'll update this instructable here, but you have to run sudo dpkg like I have shown right here. So now that we have all of the software installed, let's test things out and see how it works. Let's run sudo rtl test. Looks good. We got the right driver here. We didn't get any error messages. Everything's looking pretty good. Hit Control-C to break out of that. Okay, the next step is to actually run Predict one time to set the ground station information. We need to set our actual location on the planet so that Predict knows where we're at and knows how to predict for satellite passes overhead. It needs to know where our head actually is. So we're going to run Predict. And we're going to hit Option G for Edit Ground Station Information. And this is the default that's in here. Now, we don't need to worry about changing the call sign, but we're going to go ahead and change our latitude. You can get your latitude and longitude from Google Maps if you're not familiar with how to do this. Just go to maps.google.com, search for your address. When the little pointer pops up on the map, right-click on the pointer and say, what's here, or select what's here. And right below that little arrow, the little pointer, when what's here box pops up, will be your latitude and longitude. Now, one thing I found is that Google says latitude is degrees north positive, which is the same thing that's in here for this Predict. But Predict is looking for degrees west being positive, and Google says degrees east are positive. So I get a negative 83 and some change for longitude from Google. I need to make that a positive 83 when I put it into Predict. Pretty sure this is always going to be the case. I won't say for sure everywhere else. I live in North America, and that's the way it works here in North America. If you find that it works different in Europe or in the Southern Hemisphere, please go ahead and let me know or leave a comment below for others to help them out. But if you get this wrong, your predictions are all going to be way, way off, and they won't do you any good at all, and you won't ever get a good pass. So I struggled with this for a little while before I figured out that this whole degrees west versus degrees east thing. So anyway, I'm going to go ahead and punch in my information, and I'm going to blur that out so you all don't know where I live. But go ahead and put in your details. You just hit enter to move down to the next section. But it does say on the screen here, south is negative, just for looking for degrees north. So I know mine are, I'm not going to say it out loud. And try to be as accurate as possible. That's going to help with your predictions. So it also says east negative, west longitude degrees in west. So I'm going to make mine positive. And I don't know how important the altitude is. I happen to have an idea of what my altitude is, so I'm going to type it in. Okay, now we can exit Predict. Now we need to set up WX2IMG. We need to run it first one time from the command line so we can accept the terms and conditions. So just run WX2IMG and type yes, and there we go. Now we need to tell WX2IMG where we actually are, where our base station is at. WX2IMG creates a map overlay that it puts on top of the weather map. But in order to do that, it needs to know where you're actually at so that it can calculate that overlay based on the pass information that it also gets. So we need to figure out where we're at. We know where we're at already because we put this into predict. We just need to do the same thing for WX2IMG. We do that by creating this text file in the root of our home folder called dot, it's a period right there, period WX2IMGRC. I'm going to use VI again. And we simply put these lines in there and substitute our own information. Now, this is a little different from predict in that this is longitude is positive. It is an east value, so if you're in west longitude, you need to put a negative value here. So based on whatever you put into predict, you need to put this in as the negative value. Now I'm going to go ahead and put my values in here. So now that we have all the software installed, our dongle, our Rtl, our SDR dongle is working. We have tested out the Rtl Sdr software, and it is seeing the dongle and it is not reporting any error messages, so that's a good sign. It's time to write the scripts that will automate the collection of the satellite data and processing that into image files. So there's a couple of scripts we have to actually write. They're all documented here on the instructable page, and like I said, there'll be a link to that down in the description of this video, so you can definitely just follow along with what I'm doing and cut and paste right into your Raspberry Pi. First thing we have to do though is create a couple of folders. Now you can certainly change these folders if you don't like what I'm calling them, but bear in mind the scripts all refer to these folders, so if you do change any of these folder names that I'm showing here, you're going to have to modify the scripts, and I can't really help you with that. You'll have to do that on your own. So it's probably best if you just use these folders, but I'm not going to tell you what to do. So the first script we're going to actually put on here is a script that does all of the scheduling work. This is the script that will be called by the cron job nightly at midnight to actually go out for the day and look ahead for the full day for all the satellites we're interested in and schedule the reception and processing of that data. It's a pretty simple script. It's just a few lines here, and we'll just go ahead and create it. The file name is this schedule_all.sh. I'm going to use VI for this. Now you do not need to sudo this. You can just run your text editor because you're actually in your own user context. Feel free to use whatever text editor you are comfortable with. So we're going to go ahead and just copy all the lines in here. Don't forget to scroll down to the bottom and get all the lines. You do need that leading comment at the top of the page. That is important so that we get the right shell running the script. The second script here is this schedule satellite.sh. This is called by the first script, and this actually does the recursive pass through the full day once for each satellite to make sure we schedule all the passes for the day. We're going to do the same thing. We're just going to VI file name. Make sure we scroll to the bottom. Copy that. And then the final script that we need to worry about is the script that is called by the scheduler when the pass is coming over, when the satellite pass is coming overhead, to actually do the recording of the audio and then process that recording into creating a viewable image. So this script is here, receive and process satellite.sh. Now that we have all three scripts there, we have to make them executable. And we just have to run this chmod command on all three. ls -l, we'll see that they are all now executable. And now we need to run Crontab Editor and go ahead and add this line to the Crontab so that at 1 minute after midnight every day, the scheduler will run and schedule all of the passes for the entire day. Now, if you've never run Crontab before, as I've never done on this particular instance of the Raspberry Pi because this is a fresh image, it's going to ask you what editor you want to use. Now, you have a couple options. I'm going to use VI or the VIM Tiny at the end there because that's my preferred editor. And we'll capture this here. Go to the bottom. We just pen this to the bottom of the file and exit. So now that we have the job scheduled to run at midnight, let's run it once now just to schedule the passes for the rest of the day. That'll also make sure all of our scripts are right and everything's working. So this will schedule all the passes for the rest of today up until midnight, and then the scheduler, the cron scheduler, will run this script again at midnight to schedule passes for tomorrow and so on. So let's give her a go. Everything looks good. We've got some jobs scheduled, so let's move on to checking things out. We're going to run this command @q that will list out. So these are the jobs that are scheduled to run. So those are the passes that are scheduled. The next one is at 1400. It is currently 1306. So we've got a little under an hour to wait for the next pass to run and actually test and see if it's going to work. So we will be back then. Well, it's been a while. We should have a couple passes by now. Let's have a look and see what we got. If we just do a directory listing, we can see we got 2 passes here. We've got each pass has a WAV file. That's the audio recording from the satellite. There is the map file, which is the PNG image of the map overlay, and then there's a PNG file, which is the result of the WX2IMG processing, and that's the one we're after. So I took a look at these files, and the NOAA 15 pass wasn't a very good one. It didn't look too good, but the NOAA 18 pass, it was less than ideal, but let's take a look at it. Here's what we got. It's a little sketchy here, and it's not terribly large, but it was quite a ways to the east of us. We're somewhere in this area here, in the Detroit area, and the satellite is obviously centered passing way over here over New England, so it was quite a ways to our east in the past. But overall, it's not too bad, and if we just let this go, it will keep recording, and we can keep taking a look at these files and see if we get some better ones. I know I've gotten some better ones, and I will post a couple at the end of this video. Thank you for watching, and I will see you later. So hopefully, if we got all of our scripts right, this is going to work first try, and we won't have any problems. Let's give it a go. And it didn't work at all.